Okay, we're going to talk about the different types of numbers that we have. This is called a Venn diagram of numbers. It's a little different perhaps than a Venn diagram that you've seen before because normally a Venn diagram has two overlapping circles. This is called a nested Venn diagram. It's really nice because it shows you how natural numbers fall within whole numbers, and whole numbers fall within integers, and integers fall within rational numbers, and rational numbers fall within real numbers. And then over here you have irrational numbers that also fall within real numbers. So what we're going to do is we're just going to kind of review what each of these are, and as I'm going along, if you would please fill in your sheet with your examples. You don't have to copy mine, although if you can't think of anything else, please, at least put one of mine. All right, let's take a look at natural numbers. So natural numbers are also known as counting numbers. Sorry, my pen's a little fat here. And those would include 1, 2, 3, 4, etc. There we go. Let's talk about whole numbers. So whole numbers are different than counting numbers in the fact that they include 1, 2, 3, 4, 5, 6, etc., but it also includes 0. So 0, 1, 2, 3, etc. Notice the three little dots. Those are called ellipses. Ellipsis. And you use an ellipsis to denote and so on. There's three dots because and so on. You could also say etc., but you don't need to know that, I guess. All right, so counting numbers, 1, 2, 3, 4. Now we move to whole numbers. That then adds 0 to it. And now let's take a look at integers. So integers now add the negatives. So -2, -1, negative, excuse me, 0, 1, 2, 3. Notice that I put the ellipsis at the beginning and at the end because it keeps going in either direction. So integers include negative numbers now. So we're just adding on as we move through the nested Venn diagram here. All right, so now let's look at rational numbers. Rational numbers add in something new. And what would that be? That would be your decimals, right? So you could say -1/2. And your fractions. -0.15, 0, 2.6, 3 1/3, ... etc. Right? So now we've covered all of our numbers here, starting with 1, 2, 3, 4, adding 0, adding negative numbers, then adding our in-between numbers, right? Our fractions and our decimals. All right, so all of these numbers are real numbers, correct? We also have another set of real numbers. They're called irrational numbers. So irrational numbers are numbers that cannot be expressed as a fraction for any integer, and they usually have a decimal equivalent that never ends. So an example of some irrational numbers might be what? You ever heard of square root of 2? Or how about pi? There's also another one, e, which we're not really going to talk about this year, but anyway, these are some examples of some irrational numbers. We also have something that they're not real numbers. They're not unreal numbers. They're what we call, and I'm just going to go ahead and add it out to the side here, imaginary numbers. And really there's only one, and that is the square root of -1. There's some really cool math behind the square root of -1. It's actually quite interesting. The gentleman who discovered the imaginary number actually disliked the fact that it was called an imaginary number because he didn't want people to think that it didn't exist, because it does. Anyway, we'll talk more about imaginary numbers at another point. Okay, please make sure you filled in your diagram accordingly.